Okay, section 7.2 is on transformations. So what we need to look at before we look at any of these graphs is what do the numbers do to the shape of the graph. Okay, the first numbers I'm going to talk about are what we're going to call outside numbers. Okay, outside numbers are going to shift the graph either up or down, and you're just going to go with whatever the sign is. So in other words, if it's a plus a number, that means to shift the shape of the graph up, and a minus means to shift it down, just like you would expect. Okay. However, the inside numbers, and you'll see just in just a second when I show you an example what the inside and outside numbers are. The inside numbers shift the graph left and right, but you go opposite the way the sign is telling you. So, for instance, if you have a plus a number on the inside, that actually means to shift the graph to the left, and a minus means to shift the graph to the right. For example, if you have a function that says f of x equals x plus 2 squared minus 5. This squared is actually what gives it its shape. Anytime you have an x squared graph, it's going to be that U shape or that parabola shape that we've seen before. So in other words, this number, this is what's an inside number, what I was talking about. When I have x, the plus 2 is on the inside of the parentheses. Inside numbers shift the graph left and right, but you go opposite the way the sign tells me. So instead, this plus 2 actually means to shift left 2. That's going to shift the shape of that parabola, which is the U shape. It's going to shift it to the left 2. This minus 5 that's on the outside, so it's an outside number. And like we set up here, the outside numbers shift the graph up and down, and you go with the sign. So plus means to shift up, and minus means to shift down. So since this is minus 5, and it's outside, that's going to shift the graph down 5. Now, let's look at a couple of these examples of your homework. Like number 1. Number 1 is going to say, describe how the given function can be obtained from one of the basic graphs, then graph the function. So let's see, the graph is y equals x plus 1 squared. Let me get this a little bit closer. So what is that going to do to the graph? If I'm talking about x plus 1 squared, first of all, it's going to have the parabola shape since it's squared. So these questions down here, it says start with the graph of y equals. What we're going to start off with is the graph of y equals x squared. That's what the shape is. Now, this plus 1, like we were talking about, is an inside number since it's inside the parentheses. So it's going to start off with the graph of y equals x squared. The plus 1 on the inside is going to shift the graph to the left 1. So shift the graph not up 1, or excuse me, not to the right. It's going to shift it to the left. So you would choose this B and you would put x squared in that spot. So you're going to start off with y equals x squared and then shift the graph 1 unit to the left since it's plus 1 on the inside. Now, when you come over and you're graphing this in MyLabs Plus, the first thing you're going to do is come over to the toolbox and tell it that you want to graph the U shape. So choose the U shape. Then you can actually come over anywhere in this graph, anywhere in this coordinate system, and just click your mouse. Once you click your mouse, it's going to put the parabola right here in the middle of the graph, right here at the origin. And then it's going to pop up a window asking you how you want to shift it. Okay, and two of the options will be stretching. We're not doing any stretching in this section. Then there'll be 2 options that say, one will say horizontal shift, which is what this is because it's a left or right shift. The other one will say vertical shift, which is up and down. So you would want to choose the horizontal shift. So you would do horizontal shift, and then it has this number line, you would just move it over to that -1 since you're shifting it to the left 1. So you would click it there. Once you do that, it will automatically move the graph where you're telling it to move it. It'll put the parabola where it's supposed to be. All right? Same thing on number 2. Describe how the graph of g of x equals x minus 5 can be obtained from one of the basic graphs. So this one, since it's not squared, it's just plain x. We're just going to start off with the graph of y equals x. Now, since this minus 5 is not inside, because it's not inside of parentheses or anything like that, it's an outside number, which means outside numbers shift up and down. So since this is minus 5, it's going to shift the graph of y equals x down 5 units. So you choose the one that is down 5. So y equals x, and then shift it down 5 units. Number 3. All right, this one will be a multiple choice. Describe how the graph of h of x equals 1 over x plus 5 can be obtained from the graph of f of x equals 1 over x. So again, what this is this plus 5, since it's an outside number. It's not inside parentheses or anything like that. It's an outside number, which means it shifts 5 units down. So it's going to shift the graph 5 units down. And this is actually missing the D over here. And you can even put this into your y equals to see what the graph looks like. So you will have 1 over x in parentheses, then plus 5. Now let's see what that graph looks like. So see what it did. It had the graph, if this was just the basic rational graph, since the x is in the denominator, these things would just be coming like this. So what it did is it shifted it up 5. So if you're looking at these graphs, the one that shifted up 5 was that B. All right, number 4. Describe how this function can be obtained from one of the basic graphs. Then graph the function. So this one is going to start off with the x cubed shape. So it's going to start off with f of x equals x cubed. Now this minus 10, since that's an inside number, inside numbers, remember, shift left and right, but you go opposite the way the sign is telling you. So you are actually going to shift it to the right 10. Now, something we haven't talked about, if there's a minus out front like this, that actually reflects this graph across the x-axis. Let me show you what I'm talking about on the graph. If you go to your y equals, so let's just type in without the minus, and let me show you what that minus does. So if I type it in without the minus, just the open parentheses, x minus 10, go up into the parentheses to the 3rd power. So let's look at what this graph looks like. It shifted it to the right 10, so it's actually way over here in the corner. Okay, now let's see what happens when you put a negative in front of that. So if you go to your y equals and put negative x minus 10 to the 3rd and graph that, look what happened to it. It flipped it across the x-axis. It reflects it across the x-axis. Okay, let me show you a better window for this. Let's say I went from negative 20 to 20, negative 20 to 20, and graphed it. So you can see, so I made my x-axis go farther, since instead of going just to 10, it goes to 20. So you'll see the first one, when you graphed it, it looked like this. The negative going in front of it flipped it upside down across the x-axis, or reflects it across the x-axis. So that's what the negative does. So let's see. The things that are happening here is it's going to start off with the graph of x cubed, shift it to the right 10 for the minus 10 on the inside, and then reflect it across the x-axis, which would be this one. So shift it right 10 and then reflect it across the x-axis, starting with the x cubed graph. So you'll choose that one. And then, when you come over to your graph, since it's the x cubed shape, you'll choose the cubic function that'll look like that from your toolbox. Then you can go click actually anywhere on the graph that you want. It's going to put that x cubed right here in the middle of the graph. And then once you click to put it on the graph, then you're going to tell it to shift. So since we're talking about shifting left and right, you'll do a horizontal shift to the right 10. And then you'll also have an option on there where you'll be able to choose to reflect it across the x-axis. So once you do those two things, you'll show that it'll move it to the right 10 and then it'll flip it upside down. Number 5. All right, describe how the function can be obtained from one of the basic graphs, then graph the function. So again, this one, it's going to start off with the graph of f of x equals x squared, since it's a squared. Now, it's going to shift it blank units, blank 3 units. So where is it going to 3 units? This right here, since that's an inside number, it's going to be a horizontal shift, so it's left or right, but you go opposite the sign, which means you are actually, since that's plus 3, you're going to go to the left 3, and then shift it where 2 units. So where is it talking about here? This is the 2 units it's talking about, and that's an outside number. And since it's minus 2, I'm going to shift it down 2. And then, once again, you'll go to the graph. You'll pick your parabola or your squaring tool out of your toolbox, click anywhere on the graph, and then horizontal shift it to the left 3, and then vertical shift it down 2 to show these 2 shifts. And it'll move the parabola, it'll move it to the left 2, or excuse me, left 3, and then down 2, and put your parabola where it's supposed to be. All right, number 6. Describe how the graph of the function can be attained from this, the graph the function. Start with the graph of square root of x. Then shift it where blank units. So let's talk about what is this minus 6 doing. It's on the inside, since it's underneath. If it was on the outside, it would be out here. So this is an inside number, which means it's going to shift it left or right, but I go opposite the sign, because inside numbers go opposite the sign. So since that's minus 6, it's actually going to shift it to the right 6 units. Now, when we're looking at this multiple choice, the graph of x squared just simply has this shape. Okay, so I need to find out which one of these has been shifted to the right, which would, from the origin. Here's the one that would be shifted to the right. If it had started at the origin, it moved to the right 6 spaces. All right, number 7. Same thing. It's a graph of the cube root of x minus 3. So let's see, it's going to start off with the graph of the cube root of x. And what is this minus 3 going to do to that shape? Well, a minus 3, this one's on the outside, right? It's not underneath the radical, which means it's outside of that radical. So that minus 3 is actually, so outside numbers shift up and down, and you go with the sign. So it's actually going to shift it 3 units down. So if I'm looking at these choices, which one of the graphs has been shifted down? This one right here. This one has been shifted up, and this one is the original. It hadn't been shifted anywhere. That's what the cube root of x looks like when it hasn't been shifted at all. And this is where it had been shifted down 3. And then the last one, describe what's going to happen in this function. So let's see. This inside number, so that's going to shift it to the right 6. Outside shifts it up 2. And then this minus, this negative out front, reflects it across the x-axis. So let's look. The first thing I have, so this that goes in this spot right here. It'll be easier to see. It'll just give you a drop down when you're trying to fill this out. So let's see. The horizontal shift is this inside number. Since that's inside, I'm going to go opposite that sign. So I'm going to shift it to the right 6. So you would go to the right 6, then reflect it across the x-axis, and then shift it. What does the plus 2 do on the outside? So outside numbers shift up and down, and you go with the sign, so it would shift it up 2 since it's plus 2.